Put some cotton in it. Yeah, a heating pad draws out the infection. That's what old people say. Or some kind of oil drops. My husband's grandma always had this like old bottle of ice flavors from like the 1800s, and she's like, "Let me just drop some of that in your ear." I'm like, "Don't you put that? I don't even know what it is." Yeah. Usually, if you have an ear infection, you get a fever, though, like a real ear infection that you need antibiotics for. Well, that's babies do. Babies get ear infections a lot, and they have a fever. I had ear infections a lot when I was a kid. Everybody okay with this? I don't think anybody wrote it down. I don't care. So, I don't care. This is a college class. Suck it up. I know, and I'm still up teaching, good to go, and I don't drink caffeine, so this is how much sleep I get every night. So, well, I'm still nursing the baby, so I don't like to give him caffeine, so I don't drink caffeine. But I'm counting down the days until I'm done and I can break out the coffee again. But I went over a year without it. You think I would just say I'm not ever drinking caffeine again, but I'm not. Like, as soon as I'm done, I'm like drinking caffeine again. I wouldn't give my baby coffee in his bottle, so I don't want to give him caffeine. It's just how I feel about it. I didn't drink. They say you can drink caffeine when you're pregnant, but I chose not to because again, like I don't want to give my baby drugs. Do you think that's why kids are so hyper? Caffeine is a drug. Yeah. It's not why they're also hyper. I'm just saying, like, it's a personal choice for me. I wouldn't smoke when I was pregnant because I don't want to give my baby those drugs, so I don't drink caffeine. I don't smoke at all, but I'm just saying, to me, it's the same thing. Caffeine is a drug, whether you want to do it or not. That's what I don't understand. People don't smoke for 9 months and then they. It's because, like, when you're doing it for your child, it's the whole caffeine thing. Like, when I'm doing it for my child, I can't have any caffeine. But then as soon as I can have it again, I'm like, whoop, Diet Coke.
Why do you drink Diet Coke? It's worse.
I don't care. I like it. How about this question? Determine if the following points are on the graph of the equation 2x minus y equals 6. How in the world would we do that? You could graph it, but we could just, this is an x, this is a y, we could just plug in the x and the y and see if it makes a true statement. So I get 2 times 2 minus 3 equals 6. No. Not true. What about this one? 2 times 2 minus negative 2 equals 6. 4 plus 2 equals 6. Yes. No. Well, she's in calculus also, and they did not have very easy stuff today. Yes, how about that for an overachiever? She was late to calculus, if it makes it any better. I told Cora it was her fault, and she said, yeah. Anybody have a question about that? First hour. Oh, that would suck. So in this section, they give you lots of different things to graph. If you have memories of what x squared plus 4 looks like, then you can graph it from those memories. But what they just plan for you to do is to just make an XY chart. Remember that an XY chart always works. Maybe because we've taken a lot of math before, we know when we see x squared, what kind of shape should that be? A parabola. If you have other memories about what that plus 4 means, I'm okay with that too, but that's another section down the way. But we could just make an XY chart, okay? But if you have other memories, you use those memories. Those were linear. Like, they didn't require graphing. That's why that was in Unit 1, because that was all just solving equations. And those are story problems to solve equations.
So now we're gonna story problems and
I don't know. I haven't got that far, but I don't think so. When I pick points, especially with x squared, I always say make sure you at least pick some negative ones. Also know the shape. This should be a U-shaped graph. If you don't get a U-shaped graph, pick more points, right? But if we pick like -1, 0, and 1, that's probably a pretty good good start, yes. And you can use your calculator, but be really careful on your calculator, because if you plug in -1 squared and you don't put parentheses around it, your calculator can give you the wrong answer. So either use your calculator correctly or just use your brain. What is -1 squared? 1 plus 4? 5. And if I put 0 in there, and if I put 1 in there, and when you have a squared or a parabola, you want the same number to show up twice, because that means you have both sides of it. So that's a good thing there. So let's see if I can make a little graph here. We'll see how many you have to graph today. I really think you could probably just graph your own, but I do have graph paper, and eventually I'll give you graph paper when we need it.
oh, so we're actually like
You're actually graphing. Oh, kids. I don't know why you hate graphing so much.
I don't hate that.
because my graphs never work ever.
Well, we'll fix them. Make sure that you remember that these are smooth curves, not sharp, jagged edges. I will mark you wrong if you make me a sharp, jagged graph if it's not sharp and jagged. X squared is a nice smooth curve, so I can just put my little arrows on it and make that so nice and cute. Absolute value.
So would you mark off the face?
V-shaped graph, I would mark off. Intercepts, part of your homework today and part of the unit test. I'm doing better. I'm looking at the unit test when I make my notes. How about that? That's a good thing, right?
Yeah.
There are questions on the unit test about finding the intercepts. Y-intercept we're usually pretty good with because we all think of slope-intercept form, but x-intercept people forget about. But remember, an intercept means where the graph touches or intercepts the x and y-axis. And if you think about it, every point on the x-axis has a y-coordinate of 0, and every point on the y-axis has an x-coordinate of 0. So all you have to do to find your intercepts is plug in 0 for the other number and solve it, and that will always give you your x and y-intercepts. It's a really quick way to make a graph, is finding your x and y-intercepts. What's different about this from Algebra 1 is they're not limiting it to just straight lines. They're going to give you some parabolas and some other crazy graphs to find the intercepts of. But some of your homework today, I think they actually just give you the picture and ask you to find the intercepts. How about that? Seamers, not so bad. Should print these notes out for me because I kind of don't remember what's next because I did them last, like before we left for break. And I was just surprised every page of it. So my baby Nolan has his top 2 teeth in, and he has his bottom 2 teeth in, and all he's been doing all break is grinding his teeth together, and it's the worst sound ever. Like, it's driving us crazy. And how do you teach a baby to stop grinding his teeth?
You don't. You can't. You're doing
Like,
for the rest of your life.
oh, it's awful. It's not good for your teeth. And so we looked it up, and they just said it's normal for babies to do that when their teeth first come in because they never had teeth before, and they just checked it out. But I don't think Parker ever did it. But you could damage your teeth. They're gonna fall out. But some people they have to wear a mouth guard at night to keep them grinding their teeth.
I down all of my entire night.
So that's not good. Find the intercepts of the graph y equals x squared minus 4, then graph. So if you're not going to graph this, you could just graph it and find the intercepts. But if it didn't say graph and it just said find the intercepts, That's where you just want to plug 0 in. So you need to remember intercepts mean plug 0 in for one and solve for the other one. So it doesn't matter which one we do first. You pick X or Y. So if we want to find the y-intercept, all we do is make x 0 and solve for what's left. So I'm going to show lots of work on this because it's my notes. But I'm going to make x 0. So I'm going to get y equals 0 squared minus 4. Which would be negative 4. Right? Two ways you can write this. Like if it says y-intercept and you said negative 4, I'm okay with that. You could also write it as the ordered pair, right? It would mean when x is 0, y is negative 4. That would be the y-intercept. And what are we going to do to find the x-intercept or intercepts? Yeah, you just make y equal 0. And then you have to solve that. And you have two options here. One option is we could factor. Anybody have another option we could do here? Yeah, you could factor that, or you could just add 4 and then do what? And what happens when we take the square root of both sides? We would get plus or minus 2, which means there are two x-intercepts, one y-intercept. And again, I'm okay with you leaving it like this, or you could write that as plus or minus 2 with the y of 0. And the nice thing about finding your intercepts is a lot of times if you just graph those intercepts, that's enough to make a decent graph. And again, this is x squared, so what kind of shape should this graph be? A parabola.
Oh, we're not going to have any straight line.
Oh yeah, there's straight lines too. There's slope in here somewhere, I think. So my y-intercept is negative 4. So that means on my y-axis, I can go down to negative 4. On my x-axis, I know it crosses at 2 and negative 2. Does that look like a parabola if I connect those dots? Remember, smooth curves, not sharp, jagged edges. Put your arrows on the end, and that gives you a decent graph with just your intercepts. Okay with that? Okay, so here's something that well, even if you took pre-calculus, we did at the very beginning, you probably forget it. The one thing that's kind of maybe a new thing is testing for symmetry for a graph, and that's something that is definitely on the unit test. So we want to make sure that we write this down. And we're going to test 3 ways. We're going to test for symmetry with the x-axis, the y-axis, and the origin. I'm going to draw you a picture, and then we're going to write it out also. So let's draw like that. I'm going to draw this on all of them. This is my xy, and then so in geometry class, which I know has been a while also, but in geometry class you look at a graph and would say what kind of symmetry it has. We're going to do that, but we're also going to look at an equation and figure out what kind of symmetry it has without actually graphing it. But if something is symmetric with the x-axis, that means like you could flip it over the x-axis and it would be exactly the same, right? So if I flip this over the x-axis, do you agree that it would kind of look like this, sort of vaguely? The idea that you want to think about is what does that do to my point? If x, y is up here, what does that same point become down here? The x is going to stay the same. Do you agree with that? But the y is going to flip to negative, so that becomes x negative y. So if something is symmetric with the x-axis, the x stays the same, but the y changes signs. I'm going to go ahead and show you this at the same time. Like I wrote, if a graph is symmetric with the x-axis, then if xy is on the graph, so is the point x negative y. And it's up to you if you want to just write that up here, and that tells you enough, or you want to and words. Trying to give you a picture and words. Y-axis symmetry, we see that a lot, especially with parabolas, the ones we just did. That means if you flipped your graph over the y-axis, right, like you kind of fold it and it'd be the same on both sides. So on this one, it would kind of look like this. And again, think about what that point would become. On this one, the y stays the same, but the x changes sign. So that becomes negative xy. So I got a little lazy down here in my typing. But I said, if it's symmetric with the y-axis, then if xy, right, then so is negative xy. And again, I don't really memorize these. I always tell my pre-cal kids this. I just think about the picture. If it's symmetric with the y-axis, which one changes, which one stays the same? The x-axis, which one changes? And the last one is the origin. It's always the hardest one for me to think about. But the origin would be whatever's up here, it kind of reflects down here. So that would kind of be like that-ish. I don't think that should be going back up, but that's right. And if I go from up here to down here, what happens to my point? Yeah, both of them change. Negative x, negative y. Some problems on your homework today just give you a picture, and you just get to look at it and say, is this symmetric with the x-axis, the y-axis, or the origin? And it can be symmetric with more than one. It could be symmetric with none of them. But then the other part that we want to do is, what if I gave you an equation? Could we do the same thing? And that's kind of the new part. Pre-cal kids, do you remember doing this last year? We did it very early on, but we did it. Trevor, you remember doing this? We just did it. Exact same notes. I made the exact same page of notes. Well, I just said, why would I rewrite? Like, I just went and opened my pre-cal notes and copy and pasted it into this, because I was like, why would I make this? And I've already done it. All right, can I go? What? It's not mystical. So, starting baby steps here. It says plot the point 3, 4, and then plot the point that is symmetric to it with respect to the x-axis, the y-axis, and the origin. So that's just a point, not a graph, right? So you could just put plot the point 3, 4. I don't know how to shorten that up. You shorten it up. Then plot all symmetries. I feel like I need a good graph for this, but my graph is awful now. Look what happens when I put this over here. Can you even see those dots anymore? Like the grid?
Yeah.
Very, very light.
Why did you do that?
I don't know, like my smartboard updated, and so when it updated, it changed this graph. It's the same graph I've always used, but somehow the update screwed it up. I just wanted to update. It's like the iPhone. Update. Well, first of all, my iMessage stopped working over and over again. Like I had to turn iMessage off, turn iMessage on, shut my phone down, and I finally got it to work. But my FaceTime hasn't worked since I updated.
I heard iOS there, so it's weird.
You don't have an iPhone, huh?
No.
My sister got her braces off. Like I never use FaceTime, but she got her braces off, and so she wanted to FaceTime me so I could see her without her braces, and we can't get it to work. It just says connecting, and it never connects. Snapchat. I'm too old to do such things.
Yeah, Snapchat.
Okay. 3, 4, I think would be like right there. And all you're gonna do on this is make the other points. You don't even have to label like which one's which, because I would just look for them all. If we are going to reflect that in the x-axis, where are you gonna go? I take this and flip it over here, right? So the x is gonna stay the same, but the y is gonna change. So do you agree that that's going to be here. So what's that going to be? Negative 3, 4. You get this or you don't get this?
Got it good call.
And with the origin down here would be negative 3, negative 4, which I think would be right here.
We have a square.
Hooray! We're not going to connect to them. That's easy, right?
Wait, what's the top one?
This is the original one. So this is original, this is y-axis, this is x-axis, this is origin. Yes.
Okay.
Okay, let's do some other stuff.
Okay.
It is a lot of notes. I don't know a lot. But it's easy, so we can do a lot.
This is like one of our oldest class I've had today.
Because we're doing stuff. So I don't care. Don't write this down. Just look at it then. This is on your homework today. It says find the intercepts of the graph, then state whether the graph is symmetric with respect to the x-axis, the y-axis, or the origin. So, it's definitely symmetric with the y-axis. We could say that. Do you want me to wait? Are you writing this down? I don't care. Nathan doesn't write any notes down ever in the calculus. It's your grade. I don't care.
Does he have a good grade at class?
I don't think so. Nathan. He says he just absorbs it.
I think it's with all three.
What?
I think it's all three. Am I right?
I don't know. I think.
I think I am.
Someone said the y-axis. If we took this and flipped it over the y-axis, I agree. It is symmetric with the y-axis.
Yeah.
What about the x-axis? Yeah?
And
What about the origin?
Yep.
I think so, right? Do you agree with that? Like if I took this and flipped it over here, it'd be like this. And if I took this and flipped it over here, it'd be like that. I think it's symmetric with all three. So, sometimes it will only be symmetric with one. Sometimes it might not be symmetric with anything. But this one was symmetric with all three. And what about the intercepts on this? What about my y-intercept? Yeah, it never touches the y-axis, so we can say no y-intercept. And make sure when you give me the x-intercepts, you either write them as ordered pairs, or you say x is, right? So don't just write 2 and negative 2. Either say x is 2 and negative 2, like x equals, or you can write them as ordered pairs, right? So just make sure you label it so you don't get it wrong. I'm just going to write it as negative 2, 0, and positive 2, 0. Or if you said x equals plus or minus 2, I'm okay with that. X equals. If you just put plus or minus 2 and you didn't say x equals, I was okay. Oh, yeah, yeah. You with me on that? I have another one. Let me just give it.
I don't understand how that gets anything similar to anything.
What do you mean?
Like,
how do you get this graph?
how is it symmetric whatsoever to each other? I mean, it mirrors each other, but
Symmetry means, you mean with the origin?
yeah.
If you picked a point up here, like let's think about 3, 3 looks like that's up there. Do you agree with me on that? So if it's symmetric with the origin, that means if we go over here to negative 3, oh, look, maybe you're right. I don't think that's symmetric. Oh, now I'm
I
doubting
think
it.
it's supposed to be
Alright, here, hold on. Now I'm doubting this. So we take this, and if I, how do I flip this?
Here, grab the green dot. No, grab the green dot. Grab the green dot.
Flip.
Exit back.
Let go.
Grab the green dot.
Guys, you got that.
Just no.
Oh my gosh.
That hurts. Used it.
Oh, look, here it is.
But yeah, I could just tap on that. You messed it up by flipping it.
No.
Shouldn't have flipped it.
You shouldn't.
Shouldn't have flipped it.
No, it's alright. No, it's not.
I think I was tricked.
No, you flipped it.
No, you flipped it over.
You shouldn't have flipped it. You should have just rotated it.
Oh,
Oh man.
So unflip it.
worst day ever. Maybe we should just write down the points.
What do you think? I'm just doubting myself now. Do you think it's reflected in the origin?
Yeah.
No, it isn't. 3-3. Looks good enough.
I think it is
Yeah, it
too,
is.
but then I was thinking about it and I was trying to prove that it was right, and then 3-3 wasn't, negative 3-3 wasn't on there. You see
Yeah,
what I'm saying?
that's not 3-3 either. Look, your line's not even straight.
Oh, look, that's not negative 3-3.
Yeah.
That's
Negative 3-2.
negative 3-2.
Oh, negative 3-2's on there. I just counted wrong. I think so. I was having a moment there, kids.
That's sweet. Really catching up, Jacob.
3-2, not 3-3. So then we come over here and 3, negative 3, negative 2. And we really could do that with any of the points, but then I was just doubting my proof didn't work there. I was struggling there.
That's what I get. This team behind you.
Thanks, kids. Does that make any sense at all? I struggle seeing the origin one too. Like, it's the hardest one for me to visualize. But that's the way I would check. Like, pick a point over here and see if the opposite is true over here. Okay? That's what I would say to do. And I kind of picked the hard one here. All right. That was much harder than it should have been.
It's alright.
Oh my gosh. Look, wait, let's look at this one then.
Dude, it doesn't work.
It doesn't.
But look, you don't have to tell. Let's just do it together.
Flex over to Y. Go. Flex over to
Y-axis. Why did I pick all the ones that are the same? X-axis. Is this one symmetric with the origin?
Sure.
If you take this one I can see more. If I take this and I flip it down here, do you agree that that's the exact same?
Yeah.
Yeah. Does this one have both X and Y intercepts?
Yeah. Negative 2 and 2.
Doesn't have an X.
Right here, right?
Touch it.
No, it really does touch.
Oh.
It just kind of looks bad. And then 0 plus or minus 2.
Okay.
Okay? Alright, see, look. You still have 15 minutes. I wasn't sure what was left of this. I kind of forgot. So I guess we didn't even get to slope today. That's tomorrow. 15 through 27, multiples of 3. 30, and then 36 through 45, multiples of 3. A lot of them are just looking at a graph. And you have a good amount of time that you could probably get this done. So we can work together. So you can work on your own and ask a friend if you need help. But
I've seen that totally going different direction.
15.
Okay. For me.
There are 4 that you have to graph: 18, 21, 24, and 27. You can graph using what you know about graphs, or you can just make an XY chart. I don't like being back on harder than she said. Doesn't look like your work. I really do. Look, I have everything you want. I'm fine with you just graphing on your homework paper, but I have this graph paper if you really want graph paper, or I have this graph paper, or I have this graph paper as well. So I don't care if you want graph paper.
Or I have this guy.
Raise your hand and I can give you some. I'm fine with you just graphing out the paper today as well. So anybody want a graph paper? Eventually we'll be into more stuff like they only graph, but there's 4 stages. All right, I'll put my graph paper over here. Nobody want your graph paper? I'm still recording. I recorded that whole fiasco with me clicking that over. Maybe Bryce will watch